All right, so section 2. So when investing, the interest is the amount gained or lost from your original value. We kind of already hit on this, but this is just like a compare. Okay, so you're going to use initial investment of 1,000 with a rate of 5% over 5 years. Okay, so you're going to plug in 1,000 plus 1,000 times 0.05 times 5, and that's going to be for your simple interest. And then each year you're plugging in, I'm sorry, this will be the initial. I'll make it all pretty. There's a difference of 0 for this one. So the difference between these two is what this column is. Okay, so for 1 year, you're going to plug in 1 here. And when you do that, you're going to get 1,050. Okay, when you plug in 2 years into this guy, you're going to get 1,100. For the next one, you'll get 1,150. The next year, you'll get 1,200. The next one, you'll get 1,250. On this one, when you plug in, you're going to get 1,000 times 1 plus 0.05. And we're going to raise it to the first power, the second power, the third power, the fourth power, the fifth power. When you do all of that, you're going to get 1,050, then 1,102.50, and then 1,157.63, and then 1,215.51, and then 1,276.28. Now the difference, you're going to subtract this column from this column. So still 0 for this one, and then $2.50 for this one, and then $7.63 for this one, $15.51 for this one, and 26.28 for this one. Okay, so that kind of shows you that compound interest over a long period of time is the better option. So at the very beginning, it really doesn't matter, but later on, it does matter. All right, investors frequently evaluate investments based on the time it takes for a principal to double in value. How much of a difference does a higher interest rate make on how quickly a principal will double? Okay, so you're going to take this and you're going to do simple interest. Remember to always change your decimal or your percentage to a decimal. Okay, and this is annual compound interest. Okay, and these are the years that we're going to use. So when you plug in, you're going to get 10,934.43. And I'm just going to go ahead and fill in this little table. You should pause the video, make sure that you can do this on your own. If you can't, then we need to have a conversation. And I'm going to skip those and come down to here. 2, 3, 4, 7. This one, 11940.52. This one, 7.60. Go all the way down to 41322.52. Looking at the next one, 14185.19. The bottom, 163,938.71. And I'm trying to do this very quickly. Right here, this would be 19,738.23. And at the bottom, 2303907.76. So as you can see that the higher interest rate, the more initial, and then for the more within the first couple of years, and the more longer it would be, right? I'd love to make more money off of things and not have to do as much work. Oh, great. So what is the rule of 72? Okay, so the rule of 72 is going to be that your time is equal to 72 over your rate. So this is just a formula to approximate how long an investment will take to double. Okay. So R is the percentage. Okay. So in order for an investment to double, you're going to take 72 and then divide it by your rate. Okay. And R as a percentage on this one. Okay. So for instance, on this one, how long is it going to take to double? You're going to take 72 and divide it by 1.5. The number of years of investment is going to be 48 years. On the next one, 72 divided by 3, you're going to take 24 years. So when they're talking about a higher interest rate, percentage rate, it'll make more money when you are investing. So take 6 years, and then 72 divided by 22% is going to be 3.3 years. Okay. Compare the tables from question 2 and 5 above. Remember, the rule of 72 is an estimate. At what rates are the rule of 72 most accurate? And this is going to be, and this is from question number 4, actually. Okay. At what rates are the rule of 72 most accurate? When you double at 1.5, it's not as accurate. It's more accurate when you have a higher rate. Okay, so like these are more accurate. Okay, now going back to the compound interest formula, this is going to help for a periodic term. Okay, again, we've done this before, and you've actually seen this in Algebra 1 way back in the day. So we're going to use that to help us. We're going to use the formula above to calculate the final amounts for this scenario. So we got an investment of $1,000 at a 5% interest rate for 5, 10, 15, and 20 years, looking at 4 different compound periods. So we got annual, quarterly, monthly, and daily. So just a reminder, here's our compound interest formula. Okay, and so we're going to plug in that information. We're at 5%, so that's going to be 0.05. Okay. When you plug in, you should get 1276.28. When you plug in for quarterly, that means that your in is going to be 4. You're going to get 1,282.04. And then when you plug in monthly, that's 12 for in. You're going to get this. Okay. Daily, that's 365 days. Okay. And I'm going to do this last column as well for this last row. Because all we want to do is compare. You should be able to do this one on your own. Okay. Now, how does the number of times compounded per year affect the increased value of the principal? So they increase your return as you increase the number of times it's compounded. So we went from this to this. We make more money if we're compounding daily, just with the same interest rate. This is probably the most important thing that you are going to learn. A future value of the money. So I would write this formula down because you're going to need it. So looking at number 9, says, let us assume that a sum of money says 100,000 is invested for 2 years at 8% interest. What will be the future value of the sum invested? Okay, so we're going to take this formula and we're going to plug it in. So we got future value. We want the present value times 1 plus the interest rate over n raised to the n times t. Okay, so the principal amount is 100,000. We're going to say 1 plus your interest rate is 0.08 because it was 8% interest for 1 year or 1 time a year. For 2 years, once every year. Okay, and when you plug that in, it's going to be 116,640. And that would be our future value after 2 years at an 8% interest rate. Ooh, whoops. Okay, below is an extract from the standard chart bank deposit rate, reoccurring deposit, available for various periods. Now let's assume what you decide to invest for a period of 6 months. Then what is the value you would expect to receive? So if I do it for 6 months, it's a 3.5% interest rate. So we got 100,000. And we're going to multiply it times 1 plus 0.035. And we're going to raise it to the points 5 power because it's half of a year for 6 months. And when we do that, we're going to get 101,734.95. So that's a $1,734 in return extra from our money. Okay, go ahead and take a look at number 11 and go ahead and try that one. So if you can pause. So below is an extract from the loan details of a Standard Chartered bank where the bank will lend $100,000 to its clients at an annual rate of 10.99%. The term is 2 years. Calculate the present value. Again, using that same formula we just got, trying to find the present value. Okay, so we're going to take 100,000 and we're dividing it by 1 plus 0.1099 because that's our percentage raised to the second year, 2 years. Okay, so when we plug this into our calculator, we're going to get 81,176.87. Again, this is looking at the present value. This is that second formula on the previous page. Okay, so go ahead and try these two problems, and then I'm going to put the answers up in just a second. Make sure that you're paying attention to which formula you are supposed to be using. So this one's finding present value. So we have $4,500 divided by 1 plus 0.05 raised to the 4th power. When we plug that in, we're going to get 3,702.16. So on 13, it's again asking for present value. That's 1,650 over 1 plus 0.05. This was compounded for 365 days. So 365 times 10, because we were at 10 years. And when we plug that in, we're going to get 1,000.81. Okay, and that is section 2.